transect to count fish. Be careful not to step on or break any coral when laying the transect line or quadrant or while doing the survey. Record your starting point on the slate as described for the belt method using triangulation and a compass bearing. Lay the quadrant every 10 meters starting from 0 meters. The 1 square meter quadrant is divided by string into 100 equal squares on the inside. The string squares are used for measuring coral and seagrass cover. For slow-moving marine resources, use the quadrant without the strings. Count the target species being monitored within the quadrant. Do not count outside the quadrant. Use a meter tape or ruler for measuring invertebrate size or to determine size class. For habitat health or substrate monitoring, use a quadrant divided by string into 100 equal squares. For each square, determine which type of cover is dominant and record on your slate in the appropriate column. Continue the process every 10 meters on the 100 meter tape and then repeat 5 times as in the belt method.
After properly carrying out the survey on land, you are now ready to apply the method underwater.
Following the steps carefully, lay out the 100 meter line underwater. Make sure the line is secure and not tangled. Lay your quadrant first at 0 meters and carry on at every 10 meters. For each square, determine which type of cover is dominant and record on your slate in the appropriate column. The point intercept on line transect method is another method specifically used to measure the health and distribution of coral reefs. It can be used as an alternative to measuring coral cover using a quadrant on the line transect described earlier. Materials needed are a 100 meter measuring tape, a compass, a waterproof result sheet or data sheet on recording slate, and snorkeling gear. Point intercept line transect method requires only 1 to 2 monitors. The same 100 meter transect laid for the belt transect method to count fish and the recording starting point will be used for this purpose. The following additional steps can be employed. For every half a meter, identify what substrate is directly beneath that point. Record substrate types onto recording sheet for each stop. Substrate types can be generally classified as live or dead coral or specifically as reef check indicators such as live hard coral, recently killed coral, soft coral, and bleached coral, fleshy seaweed, sponge, rock, rubble, sand, silt, and algae. Continue the process on the 20 or 100 meter tape and then repeat 5 times as in the belt transect survey method. For a 20 meter transect, there will be 40 points sampled and the percentage substrate cover such as live hard coral can be calculated by dividing the number of times it appears on the transect by 40 and multiplying it by 100%.
You are now ready to apply the method underwater.
Lay out the 100 meter line underwater.
For every half a meter,
Identify what substrate is directly beneath that point. Record substrate types onto recording sheet for each stop. The time count method is considered to be a rapid assessment survey method. It is used to measure how many marine resources that can be harvested in a specific time frame, such as 30 minutes. For example, a timed snorkel observing and recording the selected indicator species is a time count method, as is a timed walk through mangroves observing and counting mangrove crabs. Materials needed are a map of the fishing ground, a clock or watch, a whistle, paper and a pen. Again, the recording sheet needs to be prepared in advance to record all important information. The time count method consists of the following steps. Divide the area to be monitored on the map according to the number of monitors available. For example, with 5 monitors, you will have 5 areas. For each area, a starting point is determined and roughly how long it might take to move through that area. The time is agreed to and noted. Start the survey by blowing the whistle and stop the survey when the whistle is blown again at the end of the allocated time. During this time, the monitor moves randomly in the area, recording the indicator or target organism seen. The follow-on survey should be carried out in the same sampling sites surveyed earlier and ideally by the same observers. Remember also, for checking MPA effectiveness, the monitoring survey will be done inside and outside the MPA. Another form of timed count is catch per unit effort, or CPUE. When people go out fishing or collecting and they return, you record the total catch and the total time taken to get the amount they came back with. This is only possible in open areas. CPUE is the number of fish caught divided by the total hours of fishing. If 2 people fish for 4 hours each, this is 8 hours of effort. In tambu areas, you will need to use the visual time count to monitor, as you are not allowed to catch or collect from the tambu area.
Field practice will give you more experience and greater confidence in conducting biological marine surveys.
Each team is to organize data collection using agreed sampling design from both the tambu area and the adjacent harvest areas, using the respective methods they selected. Then go out and do the survey. As soon as you get out of the water from your survey, the next step is to keep the data you have collected safe and dry. Copy the raw data from your wet result sheet or slate onto a dry field record book. Always keep your field record book in a safe, dry place. It is recommended that you make several copies of the same data with members of the monitoring team, should any get lost or destroyed. After you have made extra copies, send one of those copies to your partner organization. Your partner organization will also take this information and keep it safe as a backup. If a computer is available in your community, the data can also be entered into it and saved. But don't rely on just the computer record. Keep your field record book as a backup. You must also understand what the data is telling you about your fishing ground. The data should also be presented to your community so everyone understands why the monitoring is being done and what the results are of any management actions being taken. Over time, the record will be important information for your community so they can see the changes taking place in your fishing ground. What does the data mean? How are the results analyzed and interpreted? To make your monitoring and data collection efforts useful, you must keep the data safe and understand what the data means to you and your community members. For your knowledge and to share with others, the data must be analyzed. First, you will summarize the data. For example, add up all the count marks for each indicator species from each quadrat or transect stops. Then you add them up for each 100-meter transect. For habitat health monitoring survey, you will take the sum of the substrate type cover from each 100 squares in each quadrant, and the percentage of cover is determined. For a 100-meter transect, you will average the percentages for each substrate cover at the 10 transect stops. These numbers will be compared to the data from future monitoring to determine whether the Tambu area or the MPA is working to increase stocks and improve habitat. For presentation to your community, a visual representation of the data will mean more to them than just numbers. A rectangle called a histogram is made to illustrate or visualize results where the height represents the number of selected indicator fish or percentage of habitat cover. For substrate cover, percentages can also be shown in a pie chart, where the 360 degrees of the pie is divided based on the percentage cover shown. For example, 30% is 30% of 360 or 108 degrees. An instrument to measure the degree, called a protractor, will be needed. You will need to explain how to do this with the community monitors and have them practice with their data until they know how to do these visual presentations. Having histograms also allow you to compare the data. For example, having the data of the Tambu area next to the fished area. When you have done follow-up surveys, you can also compare the results from one year to the next to see if the numbers of fish are increasing. In summary, this training video emphasizes that 1. The Tambu area or no-take areas as part of locally managed action plan can be effective tools to improve local marine resources. 2. Monitoring will help you determine if the management actions you are taking are increasing your marine stocks and or improving habitat. 3. Monitoring methods commonly used include belt transect, line transect with quadrat, point intercept transect, and timed count. And 4. Data storage, analysis, and presentation of results are equally important activities to help you and your community learn what is happening to your marine resources as a result of your management actions. Throughout the Asia Pacific region, everyone in the village is a steward of your natural resources. Those of you involved in the management of the fishing ground are resource custodians.
All resource custodians are encouraged to use this video to refresh yourselves for the purpose of monitoring your fishing grounds and proper ways of conducting this very important responsibility.
At least once a year, you review data with your community and see what it tells you about how useful the management actions are and if they need to be changed or modified.
Your consistent efforts through monitoring will contribute to management decisions in increasing your catch. Remember, information you gather will make a difference in managing and sustaining your marine resources today and tomorrow.